When you're studying any subject and trying to really get in depth, it's useful to make for yourself some quick reference material, prepare for yourself some quick reference materials so that you don't have to be looking stuff up all the time or opening a tab and doing a web search. You can just have it right there handy as you're developing the skills and memorizing the things you need. So I am going to show you, this time I'm giving you some guidance for things you can have in your quick reference materials. And when you have these things handy and printed out, you can just pull them out and you'll be able to do homework much more quickly and easily. So a few things. Hopefully you have from previous chemistry class a periodic table that you printed out. If not, you can print one out. You need to be able to tell where metals and nonmetals are on it. With nonmetals, how many bonds and lone pairs do they typically make? What kinds of ionic charges do atoms usually have? On another sheet of paper, I often do the back of my periodic table, put prefix multipliers like milli, micro, and nano, kilo, and mega, and what they equal, the numbers that each of these equals. I would also write useful equations, like your equation for doing dilutions, or pH. And anything else that you find as you do your homework is an equation that you use that you don't want to memorize. Then there's some things unique to this class that are going to require extra pages, but you'll be happy you did it. I've printed some out. There's this basic guide to decoding organic compound names. You can find that in the folder on D2L or go to the web page, Compound Chem. He does lots of great chemistry figures, mostly just for fun and information. So here's a basic guide to decoding organic compound names, and you should spend some time figuring this out, comparing it to the videos you've looked at. This is a skeletal structure. Each end of a line is a carbon. But sometimes a line ends and you put a letter. In that case, there's no carbon here, just an oxygen. So anything that's not a carbon, you put a letter. I said anything. Hydrogen, you don't even draw. So carbon likes 4 bonds, but only 1 bond is there to this carbon. So that means there are 3 left over, and they all go to hydrogen. So you'll go over some of that in practice videos. There are implied elements. You'll need to learn functional groups. That'll be on the next page. You can have single, double, or triple bonds. You also use numbers. Each carbon gets a number assigned to it. You can learn how to interpret those. Your name will give you a Greek root for a number of carbons, and that will be the longest main chain, the longest chain with the highest priority functional group, all stuff you'll learn enough about later. And you'll be able to draw that based on knowing these numbers. So you need these numbers, meth, eth, prop, but, pent, hex, hept, oct, non, and dec, as reference, so you can easily find things. Organic molecules don't just come in straight chains, they can have branches. So you need to be able to interpret the branching. The end of the name will be the main chain, and things written out the front with a YL after them will be side chains. And here are a few examples. And then some compounds will have stereochemistry. It means they have all the same atoms, all connected in the same order. In this case, 4 carbons with single bond, double bond, single bond, double bond, single bond. But because the double bond doesn't rotate, if it makes this shape going across the bond, it's different than if it makes this shape all on the same side of the bond. And of course, hydrogens aren't shown. So you need to be able to interpret these differences, and here's where you should add something. Here's where you should add something. You want to write in that this see if I can get this to draw. Maybe I'll do a text box. I'm going to back out and try it again. Okay, now I can do my text box. This here is a trans double bond. Let's make that where we want it. So you can label that. We're going to use trans and for things on the same side, cis. So you'll want to add that onto your sheet when you print it out, because those are the words we will use. They are common to biochemistry. Biochemistry rarely uses the newest names for these. All right. We've got that. And then the last page, functional groups in organic chemistry. You're going to only use about 4 of them. I'm going to put some stars by the ones you need to know. Alkanes are considered not a functional group. That's the basic molecule, the basic hydrocarbon. Alkenes, you'll need to know. Alkynes. Alcohols. And I could go through the list, but actually, I've given you a list up here of all the functional groups you'll need to know, and you'll encounter them in your problems. You can copy that down and highlight the ones that are in your problems that you do on the homework. They have lists of functional groups that you need to know. There are a couple that aren't on this sheet. You can add them to it when you get to them later. The last thing that I recommend and that you will need to do certain problems in this course is a map of interconversions of organic functional groups. What are the reactions that can take you from an alkane to something different? And you'll have some of these pretty soon. Memorizing all these reactions is something that people in organic chemistry classes often have to do. It's not useful if you're not going into an organic chemistry class, but it is a useful skill to be able to take complex information and apply it in a specific setting. A map like this is complex information about how organic molecules react with each other. If you learn how to use this, you will have exercised, practiced that skill of using complex information. Now, this doesn't have everything you're going to see in your homework, and it has more than you're going to see in your homework. So this map may not be what you want. You may want to draw your own as you encounter reactions, referring to the explanations of problems and to the textbook. You may find, for example, that an alkene, let's zoom in, can convert to an alcohol, and this has drawn it with 2 steps or with 1 step, and it has the reagents you need to help run the reaction, to help make the reaction go. Because an alkene won't just turn into an alcohol, it needs a strong acid with it. Or it needs a weaker oxidizing acid and steam. This is a strong oxidizing acid, but these aren't things you need to know. You need to know what your homework problem asks for, and it's going to show you questions that ask about what happens if you put an alkene with sulfuric acid. So there may be more information than you need, but you can write notes that simplify this part. Over here on the polymerization side, it just says alkenes can polymerize. You have a couple of polymerization problems at different points in the course, and you may want to add notes about polymerization that are more than what's here. So sometimes you may want to simplify, sometimes you may want to add more. But this is a good starting place for your quick reference information. I'll skip back up. Here's some information that will help you if you keep it handy. Keep it in a folder by your notebook where you're writing out your homework problems. Keep it in a folder there, and when you do your homework, just pull out these 4 sheets or 5 sheets and just have them right there so that when you need them for a problem, you save yourself lots of web searching time, and you can apply your skills at using complex general information to come up with specific answers.